Thank you very much, Don. Let's move on. Our presentation is by David DeBari. David is a process engineering associate with ExxonMobil Research and Engineering, and he's been involved in the ExxonMobil Open Process Automation initiatives probably since early days. And he's going to give us an update. He presented last year. He's going to give us an update on the status of those programs within ExxonMobil as they move from proof of concept to pilot. David?
Yes, thank you. Well, hello. I am David DeBari, as he said. I don't know if I was the first one they approached, but I know I was in the first three. So I've been doing this 8 years. 8 years ago, I met this guy named Don Bartusiak and another guy named Steve Bitar, and I said, yeah, I'm in. Whatever, this sounds so great. And I've been here the last 2 years. So 2 years ago, I talked about our proof of concept. And last year, I talked about what we were going to do with our prototype. And this year, I'm going to really give you some exciting news because things are starting to come together. The one thing I hope you'll walk out of here remembering is we are way past the idea stage. All right, so I'm going to refresh you on the OPA vision. This is how we wrote it. We believe that a standards-based, open, secure, interoperable process control architecture that can promote innovation and value creation is a valuable thing to us as a company. I believe it's probably valuable to all of you. You can see the key characteristics. If you go back to last year's, you're going to see a lot of these same words. You can see our drawing here of what we think the architecture is, and this is really the forum's reference drawing. We drew an initial case, and it's been evolving and refined over the years as the forum has conducted its activity with the standards. The big thing here is, does anybody need to do new technology insertion? Anybody's management said words like, I need better security, I want to do AI, machine learning. How about the digital twin or edge analytics? We hear this all the time. Our job is to develop the technology and work on solving these problems for the business. And open process automation will allow us to have a platform to solve those problems. It's going to open up our capabilities. It's going to reduce the restrictions. We do believe that marketplace competition is important in this. It can lower the barriers to innovation. It's going to increase the value creation capability of the system. And so you might ask yourself, why have we not used a state-of-the-art DCS? There's plenty of them out there. We all have the old systems, and we're all been migrating to newer systems, and they have a lot of capabilities. Well, the high cost of technology refresh, do you really want to wait 30 years or 20 years or however long? Look at Moore's Law. Most of these processors and their capabilities will be old in 5. The integration of third-party products has been a problem that we've had for decades. That's the hard work. Two things don't talk together. How do you make them talk together? And then, of course, a lot of our systems are bundled. They are not all the parts are considered best in class. And we said, what if we could create a system that could be best in class? And the best in class is a subjective term. I'll admit that. And then we need the security model built in from the ground up. We cannot keep bolting on, gluing on, taping on, baling wiring on security solutions and have a solution. The hackers probably think it's funny now that they've discovered that control systems are a really interesting target. So the drawing on the right, you'll notice, for those of you who haven't seen this before or really studied it too much, the idea of a distributed control node is what Exxon thought up in the early days. And so people say, what's a distributed control node? And I have permission to show this. I did it 2 years ago. With about 3 paragraphs of description, and I think watching Don give a presentation, our friends at Intel invented this. It's got about 4 channels. It's got a processor. And the nice thing is, and one of our bullet points is, interchangeability hardware. So if you don't like this processor and you want something bigger, you want to do edge analytics, you take this one out and you put the purple or the black one or the red one, whichever is the bigger one, you plug it back in and move on. And this was such a neat concept that encompassed our ideas. And I want to say thank you. And I'm going to echo what Don said. Go see these guys that have worked with us. They are, specifically Intel has carried this concept further. They continue to talk to us, and I think they need to talk to you all as well. Okay, so we'll talk about the schedule a little bit. So this is a schedule we've been showing. We've done our proof of concept. I came 2 years ago and showed we thought we could do interchangeability, portability, interoperability, and with Lockheed Martin's help, we did it. We had a bunch of suppliers help us with their equipment and their software, their components, as we say. And with that, we showed it is entirely possible to build a system that can demonstrate these attributes that we have espoused in the forum and Exxon has been talking about for quite a while. Last year, I told you we have a prototype plan. This is an area that we're currently focusing in. We're sort of in the middle of, almost done. We took Lockheed Martin as our original partner. We added Wood to that, and the three of us created a system to put on a pilot unit in our Clinton, New Jersey research facility. And I'll give you some more notes about that in a minute. And the second piece we're currently working on is our test bed. So the idea we have is there's a bunch of questions we haven't answered for ourselves. There's things, the standards that we're talking about in the forum. We want to try them and test them at scale and figure out some of the nuances because, you know, realize standards are kind of the big picture and there's always a tactical effect here. You've got to know how to put it together and what it might mean and what the limits might be. And so that's our test beds help us answer questions and get us to a point where we can actually build industrial field trial. Now, we also added to our pool on the test bed, we're going to use Yokogawa as our system integrator. I believe the announcement went out today officially on that. Many of you knew that before. And the industrial field trial is going to be conducted by ourselves and some of our collaboration partners who are end user companies who are also members of the forum. And they've agreed to work with us to do tests and conduct experiments and then go out and get some mileage on this equipment and these systems via industrial field trials. So the idea behind the test bed is to get to a point where we can actually define and specify an industrial field trial system. All right, so pilot unit in our R&D facility. Probably if you took 2 or 3 of these tables and put them together and it was about 10 foot tall, that'd be the pilot unit. So that's the scale we're talking about here. It is 4 reactor trains. We test catalyst effectiveness in this pilot unit. It has hot and cold end recovery, and you can see it runs 600 degrees, 1200 psi. And it's a process. It's crude oil and hydrogen, and it's got H2S sensors around it, and it's got a safety system and a GC. So we take the off gas and send it to a GC. So this is a miniature process, and it does run at process temperatures and pressures. The flow rates are low, but it's a pilot unit. It says there's about 25 loops. There's some cascades, 130 IO, and then when you get done with all the other calculations and other things, 500. So it's not not a small, tiny system. It's definitely bigger than the proof of concept system we did. And then, of course, it has real equipment we turn off and on and operate. All right. It actually has one other feature that we'll talk about. It has an operator. So if you want to test your software or your system, the toughest test you can have is an operator. They will give you unvarnished feedback. I call it the real-time performance appraisal, where they tell you how good a job you've done and how much they appreciate you if you haven't done it well. So we have our prototype architecture, and we displayed this last year, although here you can see some count on some of the devices. Again, safety system, GC. We do talk to the enterprise system. So this thing runs tests. And one thing I did learn about a pilot unit, it does make something. It's called data. And so the enterprise system needs that data. The researchers need that data. They take it off and do what they do. The job of all this equipment is to run that equipment, capture that data, and provide it. We did use, we're using a third party, the Ignition HMI. We have OSI for our historian. We have some devices that we call intelligent I/O, and really what that is they don't do the processing locally, but we do have soft controllers that are doing the processing for those smart I/O. In this model, one of the reasons we have so many devices, we kind of went with one device, one loop. So single loop integrity model. Still, making sure works for us and the design is good. So that is our architecture, and you can see all the vendors that helped us with that, and thank you for that. So I already showed you what a possible DCN might look like, in terms of concept. You can see here also Phoenix Contact provided a device. They allowed us and helped us customize it a little bit for what we were doing with it, but it is actually their catalog product. You can see that we use the hyper-converged system, the Dell VX Rail, and that's where our soft controllers and our ignition graphics are built and served up, and the OSI historians live. And that cabinet you see is 34 by 34 inch Rittal cabinet, standard height. So that's all of it. And it sits right beside a legacy control system, which is many times this cabinet size in scope, so you can imagine. So that's what it looks like. This is roughly 10 feet from where the operator sits. So here's the real test right here. Lead operator. This is Cindy. And Cindy's not happy. Nobody's happy. And if it doesn't work right, we're not happy. And as of about 3 weeks ago, she's happy and we're happy. So she's running the lines. The systemness was probably our biggest challenge. And by that, I do mean we got security to deal with. So we did 6 zones. So we tested zones and conduits. We attempted to try some other security features that not all the software vendors were ready for. We kind of went, the big vision was the IT model of everything, and well, we had to live within the time zone, the time frames, and what we could actually do within reason there. It's got alarming, it's got messaging to the operator, so there are messages. There is alarm system. Getting the engineering tools and system management and the history all working together. Those are some of the challenges. So systemness is one that's, it's important for all of us, and it is sort of one of these things where we spent some time getting it right. But it's real happy. So I'll tell you a story. Last Friday we were talking to the site, and the engineer starts with a story about how the line shut down on Tuesday. And we had not heard anything about this, and we all start getting a little nervous about, we're going to have to go fly to New Jersey and fix some problem. Oh, no. The filter, one of the filters in the system plugged, which is normal. Shut down the system, which is normal. Operator cleared the plug, started back up, which is normal. An hour later, everything's fine. It's like, oh, okay. Please tell me it hadn't been down 4 days and you hadn't said a word. But, a lot of nervous laughter on the phone. But it's really interesting. So it's not just steady state, it's going through normal operational cycles. So this is a full-featured configuration. The great part is it's running real. You can see the unit out the window in the picture. All right, so let's move past the prototype. We'll run it for a few months, and sadly, we will actually have to go back to the legacy control system because it's customized, not production product. But we're going to move on to the test bed as well. And you can see this is a picture. Yokogawa is our system integrator, and this is not too far from the campus where we work. They set up a facility, and they've started populating it and setting it up. And the goal here is to stand up a system that we can then use for the test bed. Okay? So it has 3 stages. The first stage is to stand it up, which is what you see here. Power it up, stand it up, get the software working. Our second stage we've asked them to do is to extend the test bed, basically add some new devices to it. And that's just basically the whole innovation. This is system integration. They're good at it. The third stage is where we involve our collaboration partners, and we start doing experiments and tests to gather information, understand how to design a system, learn how the architecture will, how it all fits together. We did decide on a process. So we have an architecture, a basic architecture, and it does follow the prototype model, of course. We have a simulation, and we're going to do a separations tower. So the proof of concept was a fired heater. The prototype, of course, is an existing unit with 4 reactor trains, and we're going to do a separation tower for the test bed, just so we have something we can play with and push it around with the system. Speaking of collaboration partners, so we've started engaging with our collaboration partners to talk about the experiments and tests and components and ideas that we might have. The ideas, they're all members of the forum. They all believe in the same end goal that we have. You can see it's a band of 8 now. Last year, if you count, it was a band of 7. So we have had some people join with us. That's great. The whole goal here is that we gather enough information that we can all go our separate ways and conduct our industrial field trials. So we do intend to share information about the functionality of the system, but not how we use it and not our applications, of course. We have to definitely non-competitive learnings. Just learn how we all use control systems and what works and then where the standards are at, or, as you look at what the forum is doing, then you have to learn how to build it. So standards don't always tell you, well, what's the network topology look like? What's the best network topology? What's your throughput requirements? All right, so let me tell you about some of the experiments. So this is just a partial of our brainstorming list we formed. And as you can see, it's it's quite a number of things, just sort of the kinds of questions. We've done a lot of continuous control in our proof of concept and our prototype. And so we want to test out some batch and sequence ideas, because some of the people who are in the forum have a lot more batch than we do, and they're going to want to know. And some of our collaboration partners use a lot more batch. So there's definitely some issues there that we want to resolve in terms of how would it work and how does it function and performance, all of those questions. The goal here is to get to technical readiness, which means you have to have the answers to the questions. Things like containers and orchestration, some security topics, probably a lot more of that. Cybersecurity, you come to this conference, and I feel comfortable until I go to Monday's sessions, and then I walk out thinking, oh no, stuff scares me. I'm glad there's some smart people working on those problems. Things like clock synchronization. So we all heard TSN's coming. Well, okay, there you can do it with TSN. You can do synchronization right now. Well, how does that work in this kind of environment? Some new DCNs. And so the collaboration partners are going to define the experiments we want to run, but as part of that, we also define the equipment and the components that we need to do that, whether it be software, hardware, or a combination of the both. And so we will be probably reaching out to people to explore what is possible and test some ideas. So we want to test the ideas, and we're going to need some equipment to run it. Obviously, wireless instruments are big. Some of the mobility issues, just understanding how all this stuff is put together. The App Store idea, which is really interesting. We're doing some things in the forum right now, but about standard interfaces, and the idea being, what if I could buy libraries from vendors but not run it on their system? And so my theoretical example is my flow loop is one vendor, and my level loop is a different vendor, and my pressure loop is a different vendor, and my pH loop is another vendor, and on and on. You could just pick and choose what you want to do. And the idea of the App Store, it's the same thing. You don't have to use what your cell phone vendor has sold you. You can go get what you want. And if you don't like that, you can get something else. Now, I think we would test it a lot better than we usually test the apps we load on our phone, but that's just due diligence and risk management in our world. Okay, and I already told you we did some of the security options with zones and conduits, and we think there's more to understand about that. I will say this, having set one up, process control engineers like to set themselves up with every privilege under the sun, right? They call it God mode, right? And the interesting piece is when you start enabling good cybersecurity, that doesn't work. The system takes over and it cuts you down. I mean, we did the classic, oh, that device isn't talking, let's just talk to it with another device. So we moved the cable. Let me tell you what, these new devices are smart enough, that's it, over. And oh, by the way, to unlock it, you gotta have serious privileges that we didn't even have. So it was a lot of fun, learned a lot. I think I can see the beginnings of cybersecurity. We did not bog the system down with cybersecurity, and that's a good thing. And I think that there's still more capabilities that need to be implemented, designed, proved, tested, and that's what we'll be doing. At the bottom, you can see the network design and protocol performance along with pub/sub. We did a little bit of pub/sub in our proof of concept, but we really didn't stress it, and we didn't really take it to the limits. We just showed that we could do it. And we did it alongside regular client-server type connections. And we need to do more of that. Obviously, network design is something, this is a network-based system, so we gotta understand the architectures and the topologies. So these are some of the ideas. We will be documenting these and planning for them in the stage 3 part of our test bed. All right. So, we believe open process automation will enable the step change. This is not incremental. This is not an enhancement. This is a step change in your ability to use innovation and create value. Now, whether you do it is really up to you, but I think all of us are being told by our companies this is what they want. They want more from what they have. Innovation and the ability to create value are going to be keys to that. We did the proof of concept with Lockheed Martin, and thanks to Lockheed Martin for being there. They're a really creative bunch. Definitely not control system, legacy involvement. You could say a lot of what they do kind of looks like a control system, but they're not really from our world, but they could do this. It was great. We showed interoperability, interchangeability, and portability. So that was the proof it can be done. Obviously, our prototype is well underway. We've done the factory acceptance and the site acceptance, and with the help of Lockheed and Wood together, we put this together, and it is running, and it is so far so good. We like what we're seeing. We think we'll get to a point where we're going to collect enough data. It's robust. It is not permanent, but that's okay. I will tell you more about the operator. So I told you the operator is the toughest test you can have. When we went to factory acceptance test, I think it took 7 minutes for her to find something she didn't like, and it took her 23 minutes to do something we never thought was possible. So almost immediately it was like, oh, we thought we knew what you wanted, or we thought we heard, it's kind of the kind of stuff, when I said blue, I didn't mean that color blue, or why is this over here, and why can't I press 4 buttons at once? And so, that was good. It was a good test. So we're gonna work with our collaboration partners. We're gonna work on the test bed. We're gonna answer questions, and then we'll have enough information that we can design and build an industrial field trial. And our partners intend to do the same. We'll all have our results, compare notes on the system part of that, and we can validate whether we've got good designs or we've missed any tricks in that effort. So this fifth bullet is really important. We must have end users that want to participate and are saying they want this. It's important. We need suppliers to provide the products that we've asked for as a group. And the forum is quite a large group now. There's over 90 companies. There's a lot of pretty good size end user companies involved, a lot of various markets and industries represented there. And so the big story is we need the participation of the end users and of the vendors and of the suppliers to make open process automation a working, functioning marketplace. And for those of you who are not part of the forum yet, and I hope it's a yet, please join. Those of you who are members, please continue participating. If you have interest in the forum, Mr. Mike Hickey has been sitting out at our booth in the main hallway there, and he'd be more than happy to answer questions about how your organization can become involved in the forum and help us define this standard of standards, which will give us these features. I think that's it.